So, good morning to all. So, today, this is our second lecture on operating system. So, in the previous lecture, we have seen the two topics from the first unit, that is operating system objectives and evolution of operating system. The evolution of operating system or the types of operating system that we have discussed in the earlier lecture, that is a simple batch operating system, then multi-program batch operating system, multitasking operating system, and the real-time system, time sharing system, or parallel and the distributed system. So today, the two important points we are going to discuss, that is the function of operating system. It is also called as the components of operating system. Very important point with reference to operating system. If you want to thoroughly understand operating system, so this you must aware of the components or the concepts of operating system. And the second important point is nothing but the development leading to modern operating system. These 2 points we are going to cover in the today's lecture. To start with the components or the functions of operating system, a very basic function of operating system is the process management, then the memory management, the file management, IO system management, secondary storage management, networking, protection system, and command interpreter system. So we can say that these are the basic building block of an operating system. So if one can ask the question, what do you mean by operating system? So OS is nothing but a big program. So in our programming language, I can say that operating system is nothing but a big program, and it has the module of process management. It contains the module of memory management. It contains the function of file management. It contains the function of IO system management, secondary storage management, networking, protection system, and command interpreter system. So OS is not a single unit, but it is nothing but the amalgamation of all these functions or the components. Getting my point or not? OS as a single entity, suppose Windows operating system or Linux operating system, or we can say the Unix operating system. So we cannot visualize yes, this is an operating system, but we can say yes, this is operating system. It is nothing but the combination of process management, memory management, file management, and etc. 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 So it is nothing but the amalgamation or the integration of all the basic functions or the basic components of operating system. So process management is the one important function that is performed, or the very basic function performed by the operating system. The memory management is the another important function. So memory in the sense, it is nothing but the main memory management, the file management, then the IO system management, the secondary storage, networking, protection system, and the command interpreter. So these are the basic functions or the basic components of an operating system. So you take any example, you take any operating system, whether it is a Mac operating system, Macintosh, whether it is a Ubuntu Linux operating system, whether it is a Windows operating system, or whether it is a Unix operating system, or whether it is a mobile OS, iOS, for example, or Android operating system. So it may be any variant of operating system, but the functions, these are the basic skeleton, or these are the basic function. The functions performed by all these operating system are the same. Your Android OS or your Windows OS or your Linux OS, they have to perform the process management. Each and every operating system, it has to perform the memory management or the file management. So these are the basic functions. So if we understand the basic function, if you clear the concept of the basic functionality or the components of operating system, then it will be very easy to understand the Unix, the Linux, Windows, Mac, or even your Android iOS. Getting this point? Now we'll see in detail what is the meaning of process management, what is the meaning of memory management, file management, etc. etc. The first function is nothing but the process management. So to start with the process management, you must know what do you mean by process. So you know that the program is nothing but the passive entity. It is nothing but the set of instruction. For example, if I write a program addition of two number, you take the input from the user, that is enter the number 1 and enter the number 2. So you are going to add these two number and you are going to save that program, for example addition.c, right? So this is nothing but a program and it is nothing but the passive entity. Now when you save this program in a C language or in a C compiler by using .c extension, then you execute the first, you compile the program, you check for the syntax error or semantic errors, then the program is converted after compilation, the program is converted into .obj file, and then you actually run that particular program. Getting my point or not? And if you run that program, that file is now becomes .exe or addition.exe file. So first is the .c file, then .obj file, and .exe file. So this is the program is now converted into the process. So meaning is that program is your passive entity, whereas your process is nothing but your active entity. So process or the program in execution is called as the process. Getting this point or not? Program in execution is called as the process in a simple word or single line definition of the process, right? Second important point is that while so this a.exe or the addition.exe, when the process is running, it requires certain resources. Resources means what? Already we have discussed, there are hardware resources or there are software resources, right? So hardware resources means they require processor, they require main memory, they require inputs from the keyboard or the user, they require some mouse input. So any input they require, or even touch screen is a one type of input resource. And output resources are nothing but your video, or output is nothing but your printer, or output is any sort of output the program is going to give. So different type of input output resources, hardware resources, and the software resources the process is required during its lifetime. So what is the function or what is the role of operating system in the process management? So operating system is responsible for the following process management activities. The very first is nothing but the creation and deletion of the user process and the system process. So generally there are the two types of processes, that is they are called as the user process and the system process. So user process are the processes they are useful for the user. Suppose I have written a program. I have written a program in Java language, key say for example someone library management system. So that is that program I have written. So and I execute that particular program. So the user has created some software and he has run that particular software called as the user process. Then what is the system process? System process, or generally it is called as the operating system processes. They are useful to run your operating system. Means the presentation which you are visualizing right now, it is one process or it is handled by one process, right? So each and everything that is handled by your operating system or that is required for your operating system is called as the system process. So two basic category of the processes, user process and the system process. So the role of operating system is to create the user as well as the system process and to delete the user as well as the system process. And when you create a process, then you need to allocate, you in the sense operating system need to allocate the resources to that particular process. Means OS has to assign the CPU to execute that particular process. OS has to assign the main memory to execute that particular process, because without main memory, the process cannot be executed. So whether it is user process or whether it is a system process, it requires processor, it requires main memory. Then it requires input to be taken from the user. Then they requires output, right? So each and every process they require resource, and it is the duty of operating system to provide the different resources and to get that particular process completely run in the system. Process synchronization. Synchronization means there is not a single process running in the system. There are n number of processes. So if we think of operating system, any operating system, Windows, Linux, Unix, Mac, or Android, iOS. So this OS is not a single. Just already I have said that it is not a single entity, but it is nothing but the integration or amalgamation of small entity or small processes. So if we think that okay, this is a single operating system, but this operating system is nothing but the integration of n number of processes, right? So these processes must be synchronized with each other. The action performed by each process must be synchronized among themselves, right? Then the process communication. While process they are in a running state, so n number of process they are currently in a running state, they are currently in execution state. So definitely there must be proper communication, process communication between them. Without communication, they cannot run. And the next or the final important point regarding the process management is nothing but the deadlock handling. So deadlock means what? Suppose if the system enters into the deadlock state or hang state, then operating system has to tackle or operating system has to resolve that particular issue by deleting some processes or by adding some resources, and it has to handle that particular deadlock or that particular hang situation of the operating system. So process management, so main important function or the basic function of operating system is nothing but the process management. The next function of operating system is nothing but the memory management. Now, memory management means it is nothing but the main memory management, or it is the RAM memory management, right? Or it is the volatile memory management. So, in the first case, that is nothing but the process management. Each process need processor, means CPU for its execution, and operating system allocate the processor to the process for the execution. That is the first case. Now, in the second case, if the operating system, if the process requires processor, then it also requires the space where it can run. So, where is the space where that process can run? Process cannot run in the air as it is, right? So, the space is nothing but your main memory, or it is nothing but one can say it is the RAM memory available. So, you have 1 GB of RAM, you have 4 GB of RAM available nowadays to your laptop or to your machines. So, the RAM is nothing but where your all processes they are running. So in other way, or in vice versa, we can say that if a process want to execute, or if you want to execute a process, that process must be bring inside the main memory. So without bringing that process inside the main memory, your process cannot be run. So whether it is a user process or whether it is a system process, all the processes must be situated or must get loaded inside the main memory for their complete execution. In this point or not? So, operating system is responsible for following memory management activities. So, first is nothing but the keep the track of which part of the memory is currently being used and by whom. For example, you have 1 GB of RAM available, or you have 1 GB of memory, means 1000 MB of memory available. So, out of this 1000 MB of memory, initial part or initial 400 MB of memory is allocated for the operating system, and rest of the 600 MB of memory is now it is utilized by your user processes. So OS has to check which part of the memory is available so that it can allocate that particular part to the process. Then it has to decide which process is to be loaded inside the main memory when memory space is available. So if you want to execute a process, that process must be loaded inside the main memory. And if there is a no space available, or if there is a no main memory available to that process, you cannot execute the process. So it is very important that process must be loaded inside the main memory for its complete execution. And allocation and the deallocation of the memory space. As soon as the process get completely executed, it must be removed or it must be deallocated from the main memory so that the memory becomes free and it can be utilized for the next process or for the remaining process. So second important function or the second important component of operating system is the memory management. Now the next one is nothing but the file management. So file is nothing but the collection of related information. In our computer system, in any operating system, each and everything is treated as a file. Each and everything it is treated as a file. Means you take any data, any information, it is treated as a file. Whether it is audio file, whether it is a video file, whether it is an image file, whether it is a text file. So anything it is stored in the form of file in itself. In any operating system, whether it is Android or whether it is Windows, you are going to save your file. So OS has to see the creation and deletion of all these files. Each file is having its own property. Each file is having its own property, means they have the size, they have the resolution, then it has the date of creation, then the user of that particular file or the owner of that particular file. So all this information, the creation and deletion of the file, creation and deletion of the directories, and mapping of the files onto secondary storage, means save that files on the secondary storage. So all these functions are performed by your operating system related to the file management. And the next important is nothing but the backup of files. Say for example, file get deleted by mistake, then the OS has to retrieve the file from the backup system. So related to the file management, all this activity or OS is the responsible for this file management activity. Or in other words, we can say that it is the role of operating system to carry out the file management activity. Next important feature or next important function of operating system is nothing but the IO system management. IO means what? Input output system management. So operating system keeps record of device driver interface and it is responsible for specific device drivers. So input output means what? Say for example, your mouse is one input device, or for example, your keyboard is an input device, or your joystick is another input device, or nowadays touch screens are available. So you are going to touch on your screen, it is also one sort of input. right? And outputs are nothing but you are visualizing the output on the screen. You can visualize the output on your printer or any output device. So number of input output devices are available. So meaning is that device driver, in the sense the OS has to install the device driver of the mouse, or it has to install the driver of the printer, so that that particular device must get enable, or that particular device must get enable to get the task from the operating system. For example, USB. Suppose you insert any pen drive or USB device to your laptop, so it first check whether the device drivers are available in your laptop or in your desktop or not. So if it is available, then it will run normally, but if it is not available, then you need to install that driver separately. So meaning is that input output system management, it is to be done by the operating system itself. The next important function is nothing but the secondary storage management. Secondary storage, as all of you know, that it is nothing but the hard disk. Remember this point. The main memory is nothing but your RAM memory, or it is nothing but the volatile memory. But the secondary storage, it is called as the hard disk. Management means where you are going to save, where you are going to store all your data and information. So computer system uses hard disk as the secondary storage device. So operating system is responsible for, and it is a hard disk. You know that we have 520 GB hard disk available. We have 1 TB hard disk available nowadays. A very huge capacity of hard disk available nowadays. So it is a task, or it is the duty of operating system to save all the file, all the data, all the information on that particular storage, on that particular secondary storage. So file, maybe it may be audio file, it may be video file, it may be text file, it may be image, or it may be any database file. So each and everything must be kept on the secondary storage, and it will be retrieved as and when it required. Suppose I require a particular file, I require some program. So OS must enable, or OS must able to locate that particular file from the secondary storage and must able to bring it to the user. So this thing, operating system is responsible for a free space management on the secondary storage, storage allocation to different files and the data, and the disk scheduling. Disk scheduling means, yes, there are different algorithms like scan algorithm, C-scan algorithm, or the FIFO algorithm that are useful for the secondary storage scheduling or the hard disk scheduling. That we're going to see. Because why they are called as important components? So we have to, we are having each unit, one unit on process management. We have to study memory management in another unit. We have to study the secondary storage management in another unit. The IO system management we have to, means each and every component or the functions, each unit is dedicated to that particular unit. Means we have to thoroughly understand, we have to study the concept thoroughly in each and every unit in the operating system subject. The next important component or the function is nothing but the networking. So networking, everybody knows that. So without connecting your device into the network, it is of no use nowadays, right? Am I right or wrong? So if you cannot connect your mobile to internet, or if you cannot connect your laptop to the internet, or to the intranet or to the network, it is of no use. Just a standalone system is not useful nowadays. Your machine, your laptop, or any your device must get connected with other laptop or other mobile. Then and then only it is useful to that particular user. So it is the duty of operating system to get that machine into the network. So how it is possible? So you might have studied in the earlier year or in the previous year, that is a protocol. What is the meaning of protocol? So protocol is nothing but the set of rule. So there are different protocols you might have studied. There is HTTP protocol, SMTP hypertext transfer protocol, useful for the web pages. There is a SMTP simple mail transfer protocol. What is the meaning of FTP? FTP is nothing but your file transfer protocol. So n number of protocols are available. You might have studied the TCP/IP reference model or the OS 7-layer OSI model. So where this model is, suppose a very simple example, you are connecting, you just have your laptop, you just connect it to the network, and the laptop is immediately get into the network. It start browsing the internet, or it start using the internet. How it is possible? So where it comes from? So it is the duty, or it is the function of operating system to get that particular machine into the network. So all the protocol or all this particular model, they are already embedded while writing the code of operating system. So that's why in the earlier I said that if we think that operating system is a very big program, OS is a very big program, then these are nothing but the modules which are consisting in that particular operating system. Right. So networking is one module or networking is one function. That function get run and your laptop or your machine get attached into the network. Right. So it is the and all the protocols, whether it is FTP protocol, whether it is HTTP protocol, any networking protocol, they are already their code. They in the sense the certain code is there. For HTTP, you can see you just type HTTP code for HTTP protocol on Google. You can easily visualize it. You can see the code for the FTP protocol. You can able to see it. So all this code is written while developing the operating system. When I write the code of operating system, I have to write the code of networking. Means I implement code for the FTP protocol and HTTP protocol. Each and every code is integrated in that particular networking module. So that when I run the operating system and when I connect the wire, the Cat5 cable to my laptop, the machine get into the network easy. Because it is operating system, all the functions, all the features are already integrated in the operating system. We did not have to install the networking component separately. Getting this point or not? So the basic function, the networking is also one of the basic function of operating system. The next function is the protection system. Nowadays, a very crucial point. Everybody knows that what is so we are using the digital media, right? So we all are on the online platform, and what is the importance of the protection that everybody knows? Meaning is that your data, your mobile must be protected from unauthorized access. Your laptop must be protected from the unauthorized access. Getting my point or not? So protection system, so operating system provides the desktop security, the network security, as well as the internet security. Now protection from the unauthorized access is one part, and protection from the viruses, worms is the another part. Security to your file. Suppose you have written a program, you have developed some software. So that software must be protected from the viruses. If the virus enters into the system, it may corrupt your system entire, or it may corrupt your important data or the file. So you must have antivirus, or you must have some security measures to tackle with that particular system. Or your system, you may have, suppose your mobile. So in your mobile, you are saving all your password, your bank password, your bank account, etc. If somebody hacks your mobile or hacks your laptop, then this information is easily accessible to that unauthorized access or unauthorized person. So the OS or the operating system which is installed on the mobile or the laptop or the machine, it has the feature to provide the protection with the help of password, with the help of some pattern. On your mobile, you have the different patterns, you have the different keys, or you have different facial recognition. So a number of security measures or a number of protection features are available nowadays. Getting my point or not? So this function, it is also the important function, or it is also the important component which is provided by an operating system to the user, right? The last component or the last function of operating system is nothing but the command interpreter system. So command interpreter system means, so nowadays all you are using the GUI. GUI means what? Graphical user interface. So you are using just a mouse here, right? So execute any command, so just I click a left mouse click or a right mouse click, and I can open any application, I can close the application, I can run the application. But each and every system, it has the command. So each and every function which can run with the help of mouse, that can also run with the help of command. With the help of commands, you can explicitly type the command and you can get that particular software or the application run. So in Windows, suppose I just click on the start button, and the bar open there, you just type the CMD. It will open you the command interpreter, and it will show you that yes, you can type the command just like dir. You just type the dir command, it will enlist the number of directories, right? In Linux, this particular command interpreter, it is called as the terminal. Means each and every operating system, it has its own command line interpreter where the user can enter the command with the help of keyboard. He has to type the command explicitly and get it run on that particular interpreter. So this is also one of the important component of operating system, or the basic function of operating system. So you can type and execute the various command in the command mode, or in this thing, right? So To summarize the functions or the component of operating system, so first is nothing but the process management. So you have to by heart all these things: the memory management, the file management, the IO management, the secondary storage management, the networking is another important function, the protection system, and the command interpreter system. So always there is a question in the in-semester examination as well as at the end-semester examination, as it is the first unit. The basic question: describe in detail the component of operating system. So process management, memory management, file management, IO management, secondary storage management, networking, protection system, and the command interpreter. These 8 functions, 8 components you have to describe in detail in the theory examination. Clear? I think there may not be any doubt, but if you have doubt, you can put the query in the chat box, right? So this topic ends here. Now let us start for the next topic. The second topic is nothing but the development leading to the modern operating system. So development, so already we have discussed that there is a faster development in the hardware technology. Like initially 8085 processor was available, then it evolved to 8086, then 80386, 80486, right? So for 80386 there was some operating system available, then for 80486 the some operating system was developed for that, right? So as hardware changes, the OS need to change or OS need to upgrade it to incorporate all these changes which took place in the hardware technology, right? So we can say that OS consists of different types of components, as already we have discussed. These components are interconnected and integrated into the kernel. So development of operating system is nothing but the development of kernel. So what is the meaning of kernel that we are going to see? So for designing an operating system, so following different types of structures are used. First is nothing but the monolithic kernel system. Second is nothing but the microkernel system, and third is nothing but the virtual machines. So operating system. So if I want to develop an operating system, my new operating system, I have to write or I have to develop the kernel of the operating system first. So kernel means what? Kernel is nothing but the whatever may be the basic function which we have discussed right now, starting from the process management and memory management and etc. etc. So all these function I have to write or I have to integrate into one part, and that is called as the kernel of operating system, right? So the kernel of operating system, if we see the figure here, so hardware, it may be your processor, the hardware, it may be your main memory, hardware, it may be your input devices, or it may be your output devices, etc. etc. The kernel is the core part of an operating system. So division of operating system, it is done in the 2 parts. So first, kernel handles the part of the operating system that interacts directly with the hardware. It is called as the kernel. And the shell is nothing but the part of operating system that deals with the user application. Means user cannot directly interact with the hardware. Suppose if user want to get the work done from the processor or from the system, then it has to give the command to the shell. Shell in turn they convert this command and it give it to the kernel, and then kernel will run that give the instruction to the hardware, to the processor, and your work getting done here, right? So meaning is that when operating system boots, kernel is the first part of the operating system to load into the main memory. So when you switch off your machine, all your information, all your operating system processes, they are kept on the secondary storage or on the hard disk. But when you switch on, when you power on your machine, laptop or your desktop, then all the processes of the operating system, they are brought inside the main memory for their execution. So first part is nothing but the kernel. Kernel is first brought when the machine boots. When machine boots, then the kernel is brought inside the main memory. Meaning is that we say that yes, the now system is in a running state. Operating system is in a running state. So entire duration of the operating system. So when the OS is running, so at that time kernel is in the main memory, right? The kernel code is usually loaded into the protected area of memory because it is the heart of the operating system. So that particular kernel must not get affected any other process. What I'm saying that as it is a very key component or it is the heart of operating system, the code of kernel must not get affected, must not get damaged with due to the user process. So that's why it is kept separate inside the main memory. This space is generally called as the system space, right? So all the basic functions of operating system are implemented in the kernel. So already we have process management, file management, IO management, memory management, all the basic functionalities. So in the simple word, we can say that all the functionality of operating system are performed by the kernel of operating system, right? And rest of all the things, any application related information or anything, it is nothing but just, one can say it is nothing but just cover to that kernel. So you take any operating system, you take Unix, you take Windows, you take Android, you take Mac, the kernel of operating system or the functions performed by the kernel of operating system are the same. Only the architecture, only the one can say that only the superficial architecture is different. Always the look of the Windows is different, whereas the look of the Unix is different, look of the Android operating system is somewhat different. But at the beneath level or at the bottom line, the all the functions, all OSs perform the same functionality, like process management, then the memory management, the same functionality performed by all operating systems. And it is nothing but the part, it is called as the kernel of that particular operating system. Now we'll see the first is nothing but the monolithic kernel architecture. Now, depending upon the kernel architecture, the operating system. So, for the development of operating system, you have to develop the kernel first. So, kernel can be developed in two, three different types. One is the monolithic, another is nothing but the microkernel, or another is nothing but the virtual machine. So, you can organize in simple way. You can organize your kernel program in such a way that you can have the different type of variation in the operating system. So, monolithic kernel architecture means you can see in the diagram that kernel space is there and user space is there. So kernel space is more as compared to the user space, right? User space only contains the application and the libraries, whereas the kernel space contains the file system, interprocess communication, IO and the device management, fundamental process management. So each and every functionality, it is now integrated in the kernel space. And below level is nothing but the hardware. Hardware, it is your processor, CPU, it is nothing but your RAM, it is the different IO devices, any hardware is at the lower level, and the kernel is dealing with that particular hardware devices. And kernel space is more that's compared to the user space, right? And each and every functionality, it is included in the kernel space. Means from the diagram, it is clear that user space is limited and the kernel space is more. So kernel functionality is more as compared to that particular user space. Getting this point or not? So the traditional Unix operating system uses this monolithic kernel architecture. This is the first architecture. So OS operating system that was developed in 1974, right? So Dennis Ritchie, who was the developer of C language, he has developed the Unix operating system, and the architecture of the OS is totally based on the monolithic architecture. Means kernel space is more and the user space is very less. So the entire operating system runs as a single program in the kernel, right? This program contains operating system code functions and device drivers. Most of the operations performed by the kernel is via system call. User services and the kernel services are implemented under the same address space. So due to this, what happens? This increases the size of the kernel, that further increases the size of the operating system, because each and everything is performed by the kernel itself, or OS runs as a single program in the kernel, right? So Linux operating system and the free BSD Unix operating system, they uses the modern monolithic kernel architecture. Monolithic kernel is used in Windows 95. You might have seen or you might have heard about Windows 95, Windows 98, Linux, and FreeBSD Unix operating system. The advantage of the monolithic architecture is nothing but the simple to design and implement, simplicity to provide speed on the simple hardware, and it can be expanded using modular system or the module system. And the limitation of this monolithic architecture is nothing but the if any one service fail, the entire system get crashed here, because the entire OS, it is now considered as a one kernel architecture, and the maintenance is very difficult in case of monolithic kernel architecture, and it is a fault tolerance is very low. As already we discussed that if one service is failed, the definitely entire system is going to fail here. Now let us look at the second architecture, that is called as a microkernel architecture. So see the architecture of the microkernel, and also remember the first figure, that is nothing but the monolithic kernel architecture. User space in that case, in the previous case, was very less. Here user space is very big, and the kernel space is reduced. That's why it is named as a microkernel architecture. Kernel space is reduced. Initially in the previous architecture, all the file management, process management, device driver, etc., they were in the kernel itself. That's why the kernel size was very big. But in this case, all these functionalities are included in the user space, and the kernel size is kept in the minimum or the very small size. That's why it is called as the microkernel architecture. And the below level is the hardware level, right? Microkernel kernel manages all the system resources, as the kernel is the system. But in microkernel, the user services and the kernel services are implemented in the different addresses. User space is different and the kernel space is different. Already we have seen in the diagram. The user services are kept in the user address space and the kernel services are kept in the kernel address space. Now remember the terminology: user address space and the kernel address space. This reduces the size of the kernel and further reduces the size of operating system. As the kernel size is going to be reduced here, so definitely the size of operating system get reduced. In addition to the communication between application and hardware of the system, the microkernel provides minimal services of the process and memory management. The communication between the client program or application and services running in the user address space is established through the message passing system. Suppose the microkernel want to send to get the work done from the user space, or now the modules are placed inside the user address space. So these two systems, they are communicating with the help of message passing system, right? So there is a communication through message passing. So from the user space, the messages are passed to the microkernel, and from the microkernel, the messages are passed to the user space. So they never interact. They never interact directly. This reduces the speed of execution of the microkernel. Definitely, they have to pass the message and they have to get the work done. Automatically, it slow down the speed of their execution. The next important point, in microkernel, the user services are isolated from the kernel services, of course. So if any service fails, it does not affect the kernel service, and hence operating system remains unaffected. That is the major advantage of the system, because the user space or the user services and the kernel services are totally different, so they are not going to affect each other. The microkernel is easily extendable, means you can add the code and the microkernel can be extended. If the new services are to be added, they are added to user address space, and hence the kernel space do not require any modification. Right. So the microkernel is also easily portable, secure, and reliable. So if we enlist the difference between the microkernel versus the monolithic kernel architecture, we will find that if we say basic comparison on the basic function, size, and execution. So basic microkernel, in microkernel, user services and kernel services are kept in the separate address space, just we have seen. But in case of monolithic, there is no separate space for the user as well as the kernel. They are located in the loaded in the same address space. The size, the microkernel, definitely it is having the smaller size, and the monolithic is having the larger size compared to the microkernel. Execution is slow execution, because in microkernel they are using the message passing system, but in case of monolithic, the execution is fast compared to the microkernel. The next differences is the extendable. Microkernel is easily extendable, whereas the monolithic kernel is hard to extend. Security, if the service crashes in microkernel, it does not affect working on the microkernel. So one can say it is a secure. But in case of monolithic kernel architecture, if the service crashes, the whole system crashes in the monolithic. So it is very difficult to manage this thing, and it is very hard. So code to write a microkernel, more code is required, but to write a monolithic kernel, the less code or less programming is required. Example. So it's very important. See the examples. Which operating system are based on which kernel architecture? So QNX or Symbian OS or the Linux or Singularity, K42 or Mac operating system, Integrity or Pike OS, they are the examples of the microkernel. And Linux, BSD, that is FreeBSD, Microsoft Windows, Microsoft, any Microsoft flavor you can take, Windows operating system, it is monolithic kernel architecture. Or your Sun Solaris, your monolithic kernel architecture. Or DOS, or OS 9, IBM OS 9, it is they are depend upon the monolithic kernel architecture. So see here the diagram. So diagrammatic difference between the microkernel and the monolithic kernel. On the left hand side, the microkernel is there, and on the right hand side, monolithic kernel architecture is there. So you can see here the user space versus the kernel space. User space versus the kernel space. So you can see the user space was more in case of microkernel, whereas user space is reduces in the monolithic kernel. But whereas the kernel space is very less and the kernel space is very high, less in case of microkernel, but it is big in case of monolithic kernel. So all the basic IPC, virtual memory, scheduling are in the microkernel, but all the application, Unix server, device drivers, and file server, they are kept in the user space in case of microkernel. But in case of monolithic, so all IPC, file system, virtual memory management, device driver, etc., all these things are kept in the kernel itself. That's why the size of the kernel is more, and in case of microkernel, the size of the kernel is very less. So diagrammatic difference representation between the microkernel and the monolithic kernel. I think these points are clear to you. The next point or the next architecture of the kernel orientation is nothing but the virtual machine or the virtualization. What is the meaning of virtualization? So virtualization means what? On a single same hardware platform. So very basic. We'll just see in a simple word. On a single hardware platform, you can able to run different type of your operating system. Suppose on same CPU, I am able to run the Windows operating system, I am able to run the Linux operating system, and I am able to run the Unix operating system. So operating system 1, OS 1, OS 2, and OS 3, I can install on the same machine. And I have to use the virtual machine manager. Now, what is the meaning of virtual machine manager? That we are going to see. So each operating system has its own applications. Each operating system is having its own applications, and still they are running on the same machine, and they feels that they are having their own hardware. Though this hardware is shared between the three different type of operating system, but this operating system they feels that this particular hardware, whether it is a processor or whether it is a main memory, it is dedicated to that particular operating system. But really it is not the case. Really it is not the case. And this is due to the virtual machine manager. This is due to this middleware which is kept between the operating system and the hardware. Getting this point or not? See, between the operating system and hardware, one middleware is introduced, and it is called as the virtual machine manager. Hypervisor is one middleware, or Java virtual machine is one middleware, or it is nothing but one virtual machine, which gives the feels that yes, this is the hardware which is dedicated to that particular operating system. Getting my point or not? Or the OS do not have to bother about the whatever may be the beneath hardware. Getting my point or not? OS does not bother about anything for which hardware it is currently using, which system it is currently using. Right? So Java is the platform independent. You know that Java language is the platform independent. It can run on the Linux platform, or Java program can run on the Unix platform. Java program run on the your Android platform. They can run on the Windows platform. How? Because they use the Java virtual machine. JVM is the popular virtual machine run executed by that Java program. So meaning is that they hide whatever may be the differences, underlying to that particular machine. The program do not bother about the underlying differences. It gets simply run with the help of that virtual machine. It may be Linux OS, or it may be Windows OS. It may be any kind of operating system or any kind of hardware devices. But the virtual machine hides all the differences, and the program runs successfully. That's why it becomes platform independent with the help of this Java virtual machine. Getting this point? So the virtual machine or virtualization means it running multiple machines on a single hardware. The hardware is invisible to the operating system. OS only sees the output picture. The virtual machine monitor, or the VMM, interacts with the hardware. It is a technique for hiding a physical characteristics of computing resources. This includes making a single physical resource appear to be functional as multiple logical resources. This is divided into two categories. One is the platform, and second is nothing but the resource virtualization. Platform virtualization means Think that yes, they are using their own platform, but it is a virtual platform. Virtual means which is not real. The actual meaning of virtual machine or virtualization is which is not real, but it appears to be real to that particular OS or to that particular system. Resource virtualization. They think that these particular resources are purely dedicated to me, or in the sense Windows or Linux, but they are not actually so. Their resources, they are virtually, really they are used by different types of operating system. The hypervisor is the virtualization platform that allows multiple operating systems to run on host computer. So, as already discussed, that hypervisor is nothing but one can say it is the middleware. So it hides all the differences of the beneath hardware, and OSs run on the hypervisor. So VMware is a popular virtualization used for operating system. In pure virtual machine architecture, the operating system gives each process in that it is the only process on the machine. See carefully, huh? What is the statement? In pure virtual machine or in virtualization architecture, the operating system gives each process illusion or the impression that it is the only process on the machine, but it is not actually so, because it is a virtual, it is not real. Each user interact with the computer by typing commands on the virtual machine. Each user directs the virtual machine to perform different commands, and virtualization is the abstract layer that separates the physical hardware from operating system to increase the resource utilization and the flexibility. So, what is the function? You may have the question, why you are going for the virtualization or the virtual machine? So, basic idea is to have the resource utilization and the flexibility of your hardware. It allows multiple virtual machine with heterogeneous operating system. Heterogeneous in the sense, one kind of operating system, Linux, Unix, Mac, Debian, or one can say your mobile Android. They are different category, or they are called as a heterogeneous type of operating system. So heterogeneous, so such operating systems to run in isolation, side by side, on the same physical hardware or the same physical machine, but they do not interact, they do not clash with each other. There must not be any clashes between the Windows and, so there must not be any clashes between the Windows and your Unix operating system. So this virtualization or with the help of this virtual machine. So each virtual machine has its own setup of hardware, that is RAM, IO devices, etc., upon which the OS application are loaded. So Java virtual machine JVM is the most popular virtual machine nowadays. Then virtual machine tends to be less efficient than real machine because it is not real, it is virtual one. That is, the efficiency is less because they access the hardware indirectly. Okay, so that's all about the development leading operating system, kernel, microkernel, monolithic kernel, virtual machine. So operating system, it is based either it is on virtualization, either it is on a microkernel architecture, or either monolithic kernel architecture. So that's all. So the next point is now the course outcome. So in today's lecture or the today's session, we have learned the two important functions of the two important points. They are nothing but the functions of the components of operating system: process management, file management, memory management, secondary storage, IO system management, etc., etc. And development leading to modern operating system. How operating systems develop depending upon the kernel architecture, whether it is monolithic kernel or microkernel, differences in the monolithic and the microkernel architecture. The outcome attainment of the today's session is the fundamental understanding of the law of operating system. The question may ask on this today's topic are, describe in detail operating system components. As already I said that there is always a question key, describe in detail the operating system component. You have to write down process management in depth, memory management, file management, secondary storage management, IO system management, protection. Define monolithic architecture. You have to define with the diagrams. So kernel space is more in case of monolithic, right? And differentiate between the microkernel and the monolithic kernel, as I have shown you on the slide. And write a note on virtual machine. What do you mean by virtual machine? What is the concept of virtualization? What do you mean by platform virtualization and the resource virtualization? What do you mean by hypervisor? Virtual machine. So you have to elaborate all the concepts of the virtualization. The reference book, already I am telling you that you must refer the reference book. Galvin is the best book for the operating system. So all you must purchase the Galvin, and you can also refer the Stallings edition, and you start referring the NPTEL video lectures. So NPTEL video lectures means these are the lectures delivered by the IIT professors. A very good lecture, language is very fluent, you can easily understand the topic from that NPTEL lectures also. And web resources are some website resources. You can directly go on this site and you can have the discussion on the today's topic. Okay, so thank you for the today's session or the today's lecture. So we'll stop here for the today's lecture. If you have any doubt, you can put it in the chat box.